Welcome to the MSBT online learning platform. We bring you the most relevant content in an exciting digital format. Today we will be studying a very interesting module from applied mechanics which include topic lifting machine, where we will be studying some interesting facts about lifting machines and we will be practicing some of the example based on it. So let us begin. Dear students, today we will learn applied mechanics module topic lifting machines. The first objective is to understand and calculate machine parameters. Second objective is velocity ratio formulas of lifting machines. Number 3, interpretation of graph generated from lifting machine data. Following are the learning outcomes. Number 1, identify and describe component of lifting machines. Differentiate the working principle of given type of lifting machines. Determine velocity ratio, efficiency and law of machine. Find effort required and load lifted by given simple lifting machine. Interpret the graph from drawing them with the help of given data. Outcome number 6, select the relevant simple lifting machine required for given purpose with justification. Utility and relevance of this unit with respect to real life problems. Lifting machines are generally used in heavy mechanical industry. Example, pulley block, winches, cranes, etc. Lifting machines to be used in civil engineering construction industry. Example, pulley blocks, winches, cranes, loaders, lever arms, etc. Lifting machines is used in mining industry also. Say for example, pulley blocks, winches, cranes, loaders, lever arms, etc. In day-to-day life also, we are using number of lifting machines. Say for example, car screw jack or pulleys in the well for lifting the water. Now, the practical application of simple screw jack we can understand by this example. We can note here a person is lifting the car, he is applying effort here with the help of lever. Also we can note a screw. Also we can note a load, that is the load of the car which is we are lifting with the help of screw jack. Now we can understand this thing by a demo. See, the person is applying the effort with the help of lever to the screw, and because of this screw is rotating, and because screw is rotating, this car is getting lifted up. So see how fast the car is lifting up. Lifting machine helps us to understand the concept and sources of load, nature of load on the machine part and behavior of the machine member under this load. Now this information is the foundation base for the subject strength of material, mechanics of structure, theory of machines and elements of machine design. Now in third semester we will be learning mechanics of structure, in fourth semester we will be learning TOM, in fifth semester we will be learning design of machine. And for civil engineering, in second year, we will be learning mechanics of structure. To learn this subject, something we must know before learning this subject. The first thing is concept of mechanical machines. There are a lot of machines around us. We must know this concept. Second important thing, advantages of machine. The third prerequisite is input and output of the machine. Say for example, in case of a two-wheeler, we will be giving petrol as input and distance traveled as the output of machine. Friction in the machine, geometrical shapes and fundamental formulas of circumference of the circle, graph plotting, drawing, equations and units. Now, we will be focusing on the scientific definition of machine. It is a device which consumes energy to do some useful work, or it is a device which need input to do useful output work. Lifting machine. Now lifting machine is a type of machine, a mechanical device which lifts heavy loads on application of relatively smaller effort is called as a lifting machine. Types of lifting machines. Lifting machines are broadly classified as simple lifting machines and compound or complex lifting machines. Simple lifting machines, a mechanical device which lifts heavy loads at one point on application of relatively smaller effort at other point. Simple lifting machines are single mechanism machines. Simple lifting machine, we can understand the concept of simple lifting machine by a simple concept of load and effort. A load W placed at one end of the lever arm, we are applying effort at the other end, and now because of application of effort, what happens? Effort changes its position from this position to this position, and because of this, what happens? Load is going to lift. Now, this is a lever arm, it is a simple lifting machine. Second machine we will try to learn is inclined plane. In inclined plane, we can easily lift the load. We are applying effort at one point and load is lifted. Compound lifting machines. Compound lifting machine is simply a machine with multiple mechanisms, or we can say it's a combination of two and more than two simple lifting machines. Now we can see a lifting machine which is compound in nature or complex in nature. Here inclined plane is there as well as pulley is there. Pulley is a machine as well as inclined plane is a machine. So it's a combination of two simple lifting machine. It is a combination, so we call it as compound or complex lifting machine. Now first we will try to learn the simple lifting machine basic concepts. So shall we start this? Yes. Now take an example of simple lever arm. Here on one side we just place the load, and on other side we are applying the effort. Now the position of load and position of effort initial level is like this. As I apply the effort, effort goes down, and as effort goes down, load is lifted. So simply we are showing that effort displacement is y and load displacement is x. Now one more concept we try to understand here. Machines always require input. Without input, no machine works. And what ultimately we get? We get output from the machine. So we can pinpoint the output of machine by simply lifting the loads. And output of the machine we measure in terms of work done. So it is nothing but load W multiplied by distance travelled by the load. As well as we are giving input to the machine in this particular zone. Here initial position of the load and load is moving by distance y. So P into y, that is work done, and it is nothing but input to the machine. Now we are discussing about the load. So the scientific definition of load is like this. It is a weight to be lifted by the machine is called as load. The units of load is Newton, kilonewton. Second important concept we try to learn is concept of effort. Now effort you might be learning first time. It is a simply force applied in a machine to lift the load is called as effort. The unit of effort is same as load. It is measured in terms of Newton or in terms of kilonewton. Mechanical advantage. It is the ratio of load lifted by the machine to effort applied is called as mechanical advantage of the machine. Mechanical advantage is a dimensionless quantity because the unit of load and the unit of effort is same. So it becomes a dimensionless quantity. Next important terminology is velocity ratio. It is simply a ratio of distance travelled by the effort y upon distance travelled by the load x. Velocity ratio is also a dimensionless quantity. Now input of the machine. It is simply a multiplication product of effort applied and distance travelled by the effort. Effort multiplied by distance travelled by the effort. Unit is kilonewton meter or Newton millimeter. Output of the machine. Output of the machine is simple multiplication product. It is multiplication product of load lifted and distance travelled by the load. That is W into X. Unit is kilonewton meter or say Newton millimeter. Efficiency of the machine. Efficiency of the machine is also very important because it's a very common term, it's a very common parameter to measure the efficiency of the machine. So efficiency is simply the ratio of output of the machine to input of the machine. Output of the machine is given in terms of W into X and input of the machine is given in terms of P into Y. And now efficiency we generally measure in terms of percentage, so it is multiplied by 100. W into X, P upon Y multiplied by 100. Now if we rearrange the terms, after rearranging the terms, we shift P upward, we shift X downward, and ultimately we will be getting efficiency as the ratio of mechanical advantage to the velocity ratio. Types of machines. Machines are broadly classified as real machines and ideal machines. Now, as we learned about the efficiency, efficiency is varying from 0% to 100%. A machine which is having 100% efficiency is called as ideal machine, and in ideal machine friction is 0. Ideal machine never exists in the universe. We are dealing with all the machines, they are real in nature, and real machine have efficiency less than 100% or they are with friction. Friction is not 0 as far as real machines are concerned. Now real machines are classified as, for our lifting machine, it is classified as reversible machine, irreversible machine and machine at the point of reversing. The classification criteria is very simple. If efficiency is more than 50%, it is a reversible machine. If it is less than 50%, irreversible machine. If it is equal to 50%, it is called as machine at the point of reversing. Law of machine. An equation which represents relationship between load lifted and effort applied to lift the load is called as law of machine. Now the equation is P is equal to mw plus c. Now it is very interesting to know how to get this law of machine. Students, for this what I do, I draw a graph of load versus effort, and when I draw a graph of load versus effort, I will be getting a straight line. And the equation of straight line is P is equal to mw plus c. This P is equal to mw plus c is the equation of machine. Now, P represents effort applied, W represents load lifted, M represents slope of the straight line, C is effort required to start the machine. Maximum mechanical advantage, it is the reciprocal of slope of the straight line. Maximum efficiency, it is the ratio of maximum mechanical advantage to the velocity ratio. Effort lost in friction is one of the important parameter. We know effort is utilized for two purposes. One is for doing actual work and other is for to overcome the friction. So here effort loss in friction can be calculated like this: actual effort minus ideal effort. Load lost in friction, it is simply difference of ideal load lifted minus actual load lifted. Students, do you have any question? Students, we completed our first objective of this topic. Do you have any question regarding this first objective?
Yes, I have a question. How to calculate mechanical advantage?
Very nice question. It is simply the ratio of load lifted by the machine to effort applied to lift the load. I hope you all followed the answer.
Thank you.
Effort lost in friction is one of the important parameter. We know effort is utilized for two purposes. One is for doing actual work and other is for to overcome the friction. So here effort loss in friction can be calculated like this: actual effort minus ideal effort. Load lost in friction, it is simply difference of ideal load lifted minus actual load lifted. Students, we completed our first objective of this topic. Do you have any question regarding this first objective?
Yes, I have a question. How to calculate mechanical advantage?
Very nice question. It is simply the ratio of load lifted by the machine to effort applied to lift the load. I hope you all followed the answer. Velocity ratio is very important parameter as far as machines are concerned. Velocity ratio depends upon the geometry of the machine, and for determining velocity ratio formula, we consider one complete revolution of the effort wheel. The first machine we are learning at that we are going to find out the velocity ratio is wheel and differential axle. In wheel and differential axle, we find an effort wheel. The diameter of effort wheel is capital D, and an axle having diameter small d, and the ratio of capital D to small d represents velocity ratio of the wheel and axle. Next important machine is wheel and differential axle. Wheel and differential axle belongs to the family of wheel and axle. In wheel and axle, we find effort wheel with diameter capital D, but there are two axle. Bigger axle diameter D1, smaller axle diameter D2, and the formula becomes velocity ratio is equal to 2D upon D1 minus D2. The next machine we are learning is screw jack. Screw jack works on the principle of screw, and in the screw jack we clearly see a screw is there. By rotating the screw, we can make it as a simple lifting machine. The length of the handle is L, pitch of the screw is P. So the formula for velocity ratio is 2 pi upon L or it is pi into D upon P when we use effort wheel in place of handle. Next machine for velocity ratio is worm and worm wheel. Worm and worm wheel is very important machine. In this machine, we are using worm as well as worm wheel. The formula for velocity ratio is, first of all, consider diameter of the effort wheel. Diameter is here. Then diameter of the load drum. Diameter of the load drum is here. The ratio of two diameters and then the ratio of capital N upon small n. Capital N is number of teeth on the worm wheel and small n is advancement of worm wheel on one complete revolution of the effort wheel. Next machine is single purchase crab winch. In single purchase crab winch, we find diameter of effort wheel as D, diameter of load drum is D, small d. Then there are two wheels, spur wheel and pinion wheel. Spur wheel has number of teeth, pinion wheel also is having teeth. So, velocity ratio is the ratio of two diameters upon the ratio of two gears, that is gear ratio. Next machine is double purchase crab winch. In double purchase crab winch, the formula is little bit complicated. The formula is capital D upon small d. It represents the ratio of diameters. Then N1, N3, N2, N4, it represents the gear ratio of the machine. Next machine is Weston's differential pulley block. The formula for velocity ratio is 2 times D upon D minus D1. Capital D represents diameter of the bigger pulley, small d represents diameter of the smaller pulley, or the formula can be modified like this. It may be 2T1, T1 minus T2 if in place of pulley we use cogs or we use number of teeth. Next machine we are learning is geared pulley block. The formula for velocity ratio for geared pulley block is ratio of diameters capital D upon small d and the ratio of gear ratio, where capital D indicates diameter of the effort wheel, small d indicates diameter of the load drum, N1 indicates number of cogs on the effort wheel, N2 indicates number of cogs on the pinion wheel, or in terms of only gear ratio, it may be velocity ratio may be N1, N3 upon N2, N4. Students, we finished second objective of the topic lifting machine. I hope you followed number of things, but still, do you have any question regarding objective number 2?
Yes, I have a question. Velocity ratio is a fixed or a variable quantity?
Very nice question. Indeed, it is expected. Velocity ratio is a fixed quantity. Why it is fixed? Because it depends upon geometry of machine. I hope you all followed my answer.
Thank you.
Whatever data we are getting in machine experimentation, we are plotting that data in the form of graph. Now, these are the graph parameters: load W, effort P, ideal effort, effort lost in friction, mechanical advantage, efficiency, and C, effort lost in friction. Now, we are plotting these graph parameters like this. I draw three vertical axes: efficiency, mechanical advantage, and the third axis has three parameters: actual effort, ideal effort, and effort lost in friction. and there is one common horizontal axis. It represents load W. Now, the first straight line I am getting is for actual effort versus load W. Second straight line I am getting is for ideal effort versus load W. The third line, straight line, I am getting effort lost in friction versus load W. When I plot the graph of mechanical advantage versus load, I am getting a curve. And when I plot the graph of efficiency versus load, again I am getting a curve. Students, we finished the third objective of our topic, lifting machine. Do you have any questions regarding this?
I have a question. Why graph shows effort for zero load lifting?
Now, it's a very interesting question. See, C represents initial friction. There is always some effort required to start the machine. That's why even for the small load, even for the zero load, it indicates some effort. I hope you followed the answer.
Thank you.
The first objective we covered is to understand and calculate machine parameters. Second objective we covered velocity ratio formulas of lifting machines. The third objective is very important, that is interpretation of from the graph is also successfully covered. Now you are fully competent to solve the problem of lifting machine. So worksheet is given below, try to solve it. Solutions of worksheet is provided for cross verification. Now in the first example, data given is 1000 Newton, W1 is 1000 Newton, W2 is 1500 Newton, P1 is 100, P2 is 120, W3 is 2000, P3 is unknown, velocity ratio is given. Now our objective is to find out law of machine and maximum efficiency. So first of all, find out the slope of straight line. It comes out to be 0.04 and C comes out to be 60. Now, first of all, write down the law of machine and putting the value of W in law of machine, you will be getting value of P3 as 140. Most of the time, it is found that you are not writing the law of machine, and if you are not writing it, you will not get value of P3. Second important thing, maximum efficiency. It is a maximum efficiency, so the formula is 1 upon m. Most of the time you calculate normal efficiency and you will be getting 0 marks. Always express efficiency in terms of percentage only. Now in problem number 2, it deals with Weston's differential pulley block. Number of cogs on bigger block is 11 and on smaller block is 10. Law of machine is 0.05 W plus 20. Our object is to find out efficiency and also comment is asked on reversibility. So first of all, find out velocity ratio. Second, find out P. It comes out to be 45. Then find out normal efficiency. It is ratio of mechanical advantage upon velocity ratio. And just see that the value of efficiency is 50.5%. It is not exactly 50. So 50.5%, it indicates machine is reversible. Now third example is for screw jack and data is given in the tabular form. Plot this data on the graph paper. Graph paper is generally given on the last page of your answer sheet. So on y-axis we are plotting effort and on x-axis we are plotting the load. Since it is the graph of load versus effort, we will be getting a straight line, but straight line is not closing at 0, it is closing somewhere here. So we are getting the value of C. Never close this effort versus load line to 0. Calculate the slope, then measure the initial friction C and write down the law of motion. In most of the time, we commit mistake in measuring the slope. Since the graphical solution is expected, so write down the things considering the graph. Measure initial friction C. Here you commit mistake. Kindly remember to measure it and then write. In this problem, one more graph is asked, and that is efficiency versus load. So plot that graph also. Most of the time we forget to plot it and then we will be getting less marks. Some tips and tricks are for this particular topic. Always express efficiency in terms of percentage, but in calculation do not express in terms of percentage. Always take efficiency in terms of decimal value. Most of the time we commit mistake. Then be careful about units. Example, kilonewton to Newton conversion or vice versa. When efficiency is exactly 50%, machine is at the point of reversing. Velocity ratio is generally greater than 1. Slope of the straight line and effort required to start the machine is always a fixed quantity. Use graph paper to draw graph to get correct results and verify the answer with analytical calculations also. You have learned some important topics so far and we hope you had good time learning with us. Browse through our online library for more contents on the MSBT website. Thank you. Stay connected. Happy learning.